Thank you. Good afternoon. This is a really, really long talk, so I'm just going to dive straight in. No need for big introductions. More than you ever wanted to know about resource hints, and I promise you this is more than you wanted to know. This is a big talk. In fact, this talk is so large that I had to trim a little bit of it out for today's event. If you want to see the full slide deck, the full slides are available right there, the full sort of 45-minute version. So I'm just going to let you get a quick photograph of that if you would like. But this is going to be a pretty rammed talk all about performance, but kind of cheap and cheerful performance, performance that's very accessible, very easy to attain, and very, very useful. So my name's Harry. I'm a consultant performance engineer from the north of England, which goes some way to explaining the weird accent. And it's my job to help clients of all different shapes and sizes have faster websites. And that's for many different reasons, but mainly it's my job to go in and work out why their website is slow and ultimately make it faster. I do that for clients who tend to be quite large. They tend to feel the benefits of performance a lot more than smaller organizations. But the thing is, each of these clients has different needs, different requirements, certainly very different budgets. And a lot of the engagements we do might last for weeks or months at a time. And that's not a very useful thing for me to speak about. So what I've done is I've distilled the world of resource hints, which is a very quick and easy thing to implement, into this sort of this condensed talk. So no matter your kind of size or scale or budget or needs or requirements, I'm hoping that today's talk will have a lot of valuable information in there that you can put to use immediately. Real quickly, I'm a member of the Google Developer Experts program. If anybody wants information on joining this, please come and find me during the Q&A. I am, as of quite recently, a media developer expert for Cloudinary. All this stuff is fairly performance-based, and I am also a performance ambassador for a company called Shift Commerce. So anybody working in e-commerce? Right, so you definitely understand the need for performance. So it's my job now as part of this role to help basically e-commerce organizations fight performance from the inside out. During this talk, we will see a number of different types of slide. If you see a slide that looks like this, it's kind of a pro tip, a little summary, a short kind of summarization of a key point. Conversely, if you see this scary-looking slide, this is a caveat, a bug, a regression, a warning. This is something that could go wrong, so pay attention to this one. What we will find is that resource hints are a very safe thing to implement, but they do have drawbacks and caveats in certain scenarios, and they are very important to be aware of. Finally, if you look at the bottom right-hand side of this slide, there's a little camera icon. If you see a slide with a camera icon on there, it's just me recommending snap a quick picture of this, just so that as we're looking through the code examples, you can refer back to the syntax. So I haven't even mentioned what resource hints are yet. Who's used resource hints? Anybody used resource hints? Cool, I would say very few of you. That makes me look better. Okay, who's heard of resource hints? Not used them, but who's actually just heard of them? Okay, that's slightly more people. After this talk, you are going to find them so remarkably simple and useful that I guarantee you can implement at least one of them immediately. So what is a resource hint? These primitives enable the developer to assist the user agent in the decision process of which origins it should connect to and which resources it should fetch and pre-process in order to improve web page performance. My God, that is dry. How boring. That's what the spec has to say about resource hints. But practically speaking, what we really need to know is that they are simply single lines of HTML that can dramatically speed up the performance of your websites and applications. And I'm being serious, it really is just single lines of HTML. Here are three little examples. This is the syntax. It's declarative. It's very, very straightforward. We'll go into a lot more detail, of course, but this is basically as simple as I am talking. These single lines of HTML can have a dramatic improvement for your front-end performance. What you may also notice is they all belong inside your head tags. So these are things you put in your head tags, and it instructs the browser how to treat certain aspects of the rest of the web page or web application. I would recommend at some point taking a look at the specification, but the whole point of this talk is that you shouldn't need one. I've picked out the most useful bits, the most interesting bits, and the most practical bits, but of course, always fall back to the spec when necessary. The first thing I want to make you acutely aware of is the fact that these are hints. The word hint in resource hints is critical. The browser does not have to conduct or implement or execute any of these. The browser will use its own heuristics, its own sort of knowledge to determine whether or not to fire these hints. So it makes them very, very safe to implement. The browser kind of has your back the whole way. There are 5 hints we're going to look at in this talk. In the longer talk, there's a 6th hint that we don't really need to know about. DNS prefetch and preconnect. These first 2 deal with the performance cost of hitting new origins, going to new domains. So these are useful if you know that you need a domain later on, an asset from a different website, but if you don't necessarily know what exact file that you need. The last 3, prefetch, preload, and pre-render, these deal with specific URLs. These deal with pre-browsing, helping the browser to get new files that it might need a little sooner. So let's start at the beginning. The most simple, the most basic, and dare I say it, unfortunately, the least powerful of the resource hints is DNS prefetch. So who has seen or implemented a DNS prefetch before? See, that's more hands than people said they'd use resource hints. So what I realize, a lot of the time, people don't even know they're using resource hints when you absolutely are. So DNS prefetch simply resolves the IP address for a given domain ahead of time. If your application or your web page needs to hit an external domain, Google Fonts perhaps, or Typekit, you can do the DNS resolution for that ahead of time. So it's when you know the domain, but not the URL. And the syntax is completely declarative. It is as simple as this. Put this in your head tag. The browser will start looking up the IP address for youtube.com ahead of time, so that by the time you need the YouTube embed, you already know the IP address. Support for this is pretty great. It currently sits at 81%, so absolutely, definitely start using it. And continuing with the YouTube example, I think one of the most compelling sort of use cases for DNS prefetch is embedding or linking to third-party content. So what we can see here is this is an actual example from my website. I've got a YouTube embed, sits on line 154 of a certain page. When the parser gets to line 155, it panics because, oh my goodness, it's a new domain. I haven't been to youtube.com for a while. I don't know what its IP address is. This is happening way too late. Looking up the IP address for a domain milliseconds before it's required is leaving it far too late. So to get this embed, we have to step through a number of different processes: DNS, TCP, TLS, time to first byte, and content download. Predictably, all DNS prefetch will do is sort out this DNS lookup, turning the domain YouTube into its IP address. We should do this ahead of time where possible. If we know that we're going to hit the YouTube domain, we should look at the IP address much sooner. In my research, I found some interesting statistics. Common names can answer in closer to 80 to 120 milliseconds, so that's domains that you visit very frequently. Think sort of GitHub, Trello, Facebook. Less common names can be closer to 200 to 300 milliseconds. And what's interesting here is these numbers do actually sound quite small. 200 to 300 milliseconds, you're not going to lose much sleep over that. I worked with a company in the UK last year, and we worked out that if they could speed up their site by just 300 milliseconds, if they could reduce latency by 300 milliseconds, customers would spend an extra £8.1 million a year. So cutting out an extra 300 milliseconds can have real, tangible benefits for organizations of a certain size. However, more interestingly, for any of these queries that access the internet, perhaps it's a brand new domain, we hit recursive resolvers, there are DNS slowdowns, it can be anywhere between 1 and 10 seconds. So annoyingly, DNS resolution, we're working with any number between 80 and 10,000 milliseconds. It kind of puts us on the back foot. Here's a screenshot from, my clicker's double-clicking itself. Here's a screenshot from a friend of mine, a guy called Andy Davies. And this is a screenshot simply showing the benefits of DNS prefetch. And right here, it doesn't seem like much at all. All we're doing here is, before we needed these third-party assets, we instructed the browser to work out the IP address. So those little green dots are divorced from the rest of the process. We've sort of paid a bit of the time up front. Time for some bad news. DNS prefetch is implemented as prefetch in IE9, which isn't in itself problematic, but when we look at actual prefetch, that behaves completely wrong in IE9. In fact, anybody still supporting IE9? You know, it might just, we should get a drink later because it's a depressing thing to have to do. I work a lot for UK government, and I have to support IE8, right? Which is why I look so disheveled and depressed. So DNS prefetch misimplemented in IE9, but it doesn't matter for most of us. Right, that's the boring one. That's the simple one. We only looked at DNS throughout that whole process, but there's still two more steps. There's TCP and TLS that we need to negotiate. So we move forward and use preconnect instead. Preconnect will resolve the IP address and open a TCP TLS connection for a given domain ahead of time. So it's just DNS prefetch and then some. And again, if we know the domain but not the URL. A common use case for this might be warming up the connection to Google Fonts, simply linking to fonts.google APIs with a preconnect resource hint is just going to open that connection ahead of time. Interestingly, despite being younger than DNS prefetch, browser support for preconnect is actually 3% better. We've got 84% global support. But if you want to capture older browsers, you might want to use both, and I will discuss how to do that in a second. So now, the difference is that we do the TCP handshake and TLS negotiation as well as the DNS. This diagram here is stolen straight from the favorite book I ever read, the favorite technical book I ever read, which is available for free at hpbn.co. Definitely take a picture of that. The sheer cost of opening a secure connection can easily get into the hundreds of milliseconds. What you can see here is that we've got 168 milliseconds lost just to opening a secure TCP connection. This doesn't even involve DNS. So again, for companies who 300 milliseconds might equal £8.1 million, implementing this kind of stuff is a complete no-brainer. It's something you should do immediately. Here's a small screenshot of my site before I implemented Preconnect. And what you can see is all the connections that I'm opening are happening very just in time, way too late, very inopportune, very inefficient. Opening these connections way too late. By simply dropping a few lines of HTML in my head tags, I can start to pay that cost up front. Just completely divorce it from the rest of the file download process, pay it up front, and buying back hundreds and hundreds of milliseconds here. So I mentioned if you need to support much older browsers, you might want to use Preconnect with a DNS prefetch fallback. And what I had been recommending for quite some time was this really wonderfully terse syntax. It's completely valid to have two values in a rel attribute. Oh, you're all taking pictures, and I've got some really bad news for you. This simply just doesn't work in Safari. It's a bug in Safari. The bug has been raised. What you can see here is, oh, you can kind of see it here. Using this syntax in Safari simply did not work. The DNS TCP TLS is still happening right before the file download. Once again, Andy Davies. This guy's going to get a lot of mention in this talk. He's a very smart guy. He opened the bug against WebKit. This should be temporary. This should be fixed. But currently, if you want to implement this right now with the fallback, it's a little annoying, but you have to put both. You just have to duplicate it. It's a little redundant, but we can live with that. Be judicious with Preconnect. So I work with clients who have decided to implement Preconnect, and we look at their head tags, and there are like 50 entries. The first problem with 50 preconnects is you shouldn't need 50 external domains to render a page, so you need to immediately audit your third-party problem. But opening TCP connections does have overhead. Oh, that's a spoiler. Only warm up frequent and significant domains that you will definitely need. Don't warm up third parties. Colloquially, we call those fourth and fifth and sixth parties. Opening many connections definitely has a CPU overhead, and keeping connections open has a battery life overhead. So don't open connections you don't need. And Chrome has this really, really weird bug. It's technically a feature, but more like a bug. Chrome can only conduct 6 simultaneous DNS resolutions, so it can open many connections. It can only do 6 DNS resolutions at a time. I'm going to be kind. I'm not going to say it on stage, but this is such a batshit mental bug that if you buy me a vermouth and I will tell you about this DNS bug in Chrome. It is bizarre. On the subject of bugs, Firefox is a little problematic. For some reason, in Firefox 66, pre-connect just disappeared. It regressed, it disappeared, it just stopped working. So if you are trying to debug pre-connect in Firefox, if you're in Firefox 66, it will just flat out not work for you. So don't panic, it's temporary. Once again, the bug has been opened, and it should get fixed. OK, so the first two, they dealt with when we know the domain, but we don't necessarily know the exact file, the exact URL. If we're in a position where we know the exact URL that we need, we can begin to use different resource hints. The first one of these is prefetch. Prefetch is when we can download a file needed for subsequent navigation. This is pretty clever wording. This is lifted directly from the specification. I think spec writers would make great lawyers, because they're very good at getting around technicalities. This could say a file needed for the next page, but very intentionally it says subsequent navigation. Subsequent, because it could be for any next page, not the very next one. And navigation, they use that wording because single-page apps don't have pages, right? They have navigations or views or routes. This means that prefetch has to work in a single-page application environment. The syntax of prefetch, it's all getting very familiar now. It's declarative. We're just changing the word preconnect for prefetch. But what you'll notice here is we're linking to an asset, not a domain, but an actual file. The support for this is very good, 82%. So again, definitely start using this stuff immediately. And an example I normally use to explain the benefits of prefetch is, let's say, for example, we work at YouTube. And we've just built, this is getting tiring, we've just built the search results page for youtube.com. So somebody searched for, I don't know, perhaps cute cat videos, and they've got a list of thumbnails, and we as developers have a 90% certainty they're going to click one of those thumbnails and go and watch the little cute cat video. When they land on the next page, they're going to need videoplayer.js. So why wait for that? Why wait for them to arrive at that page? From the search results page, we could be clever and start downloading those assets nice and early. Simply dropping this in the head tags of the search results page will allow us to download the file, store it in browser cache, and the moment they arrive at the video player page, that file is already downloaded. It means that we've dealt with that cost, that network cost, that download cost ahead of time. So what will happen with prefetch is it will simply download the file and just drop it into your HTTP cache, just normal browser cache. What gets quite interesting is the user agent should not apply pre-processing on the response and must not automatically execute or apply it against the current page context. What this basically means is it will download the file, but it will do nothing with it. You can download a JavaScript file, it will not start running. Basically, your prefetch will download the file, but whatever invokes that file is what will actually execute it. So again, it makes it very, very safe. Prefetch is basically a pre-cache. Think of it as a pre-cache or a pre-browsing mechanism. It will not execute anything. It will drop it in your browser cache, except, and this is where things get a little weird, actually, this bit isn't weird. If you've got a no cache or no store, if you've got a no store header, the file won't be stored at all. If it gets a no cache header or there's a vary response header, it will get revalidated. And then bizarrely, there's a lot of just arbitrary stuff in sort of browser land if the file is more than 5 minutes old. Apparently, after 5 minutes, it will get revalidated. But what this means is you can start to pre-browse and download assets ahead of time to make user journeys through your site or application much smoother. In fact, it was about, I think, a year or two ago, Netflix moved from client-rendered React for their login page to server-rendered React, just for the login page. A huge performance win. The login page was much faster. And then from the server-rendered login page, they had a load of prefetchers that were fetching the next routes. So vendor.js, app.js, and whatever else they needed. They were able to prefetch that from their server-rendered login page, so that by the time you were inside the Netflix application, all of the JavaScript had been downloaded silently in the background. Pretty importantly, it is always fetched with the lowest possible priority. So because prefetch is a file for the next page or a subsequent page, it will never interfere with the current page's performance. It makes it a very safe thing to implement. Another thing I was wondering is, what happens if a prefetch starts? We start prefetching a file from a logged out page, perhaps, and we navigate away from that page before the prefetch actually finishes. Turns out this is really hard to work out because DevTools can't show you like a persistent download. But I did manage to work out that the browser is quite smart. If a prefetch is started by page A, but you leave page A before the prefetch finishes, it will still continue in the background while you're heading to page B, C, D, and so on. Now, this is where IE9 becomes problematic again. Prefetch actually acts like DNS prefetch in IE9. So whereas everybody else called it DNS prefetch, IE9 decided to just call it prefetch. Then when everyone else was using DNS prefetch for DNS, it means that IE9 will actually try and do a DNS prefetch under the name prefetch. Basically, what that means is prefetch will not work in IE9. Again, IE9 isn't much of a worry. There's no point making IE9 faster anyway. Imagine what an IE9 experience feels like. But it just means that if you try and do a prefetch in IE9, all you will get is that IP address warmed up. Right, the next one, preload. Preload is where it gets a little bit more interesting. Preload used to be a resource hint. Technically, it doesn't belong in this talk. Preload is no longer optional. It's no longer a hint. A change to the way the specification is worded means that a preload is now a mandatory fetch. So with that in mind, there is a separate specification that I would recommend looking at if you want to know about preload. But again, I'm going to distill all the most important bits for you. It's a mandatory fetch, so it is no longer a hint. This is the one where you might get into difficulty. So preload is a mandatory fetch for a file needed for the current navigation, a file needed for something later in the same page. This means it's a great way to surface late discovered resources. And I'll come back to what I mean by late discovered resource in a second. And the syntax for preload starts to get a little different. Line 1 here, you will notice a lot of familiarity. We've got a rel, and this time it's preload. We've got an href that points to an asset. But the second line brings a bunch of new attributes. And these attributes are some of them mandatory, some of them a mistake, in my opinion. But I will explain what they all mean individually. So browser support for this is 79%, so absolutely start using it. But do be aware of the caveats and the concerns. So I mentioned late discovered resource. What does that even mean? Due to the nature the web works in, it's kind of slow by default, and a lot of the assets needed for a web page aren't discovered until way too late. Think of a web font, for example. To download a web font, traditionally you have to download some HTML, which then requests some CSS, which will then build the render tree, which then will ask for a font. Let's say, for example, this takes a second. That font is a late discovered resource. Background images are the same thing. The background image is requested by a CSS file. Background image could be several hundred kilobytes. Hopefully not, but it could be. So this is now taking 1.25 seconds to get that file. Is anybody building a client-rendered JavaScript application? Yeah, there's more than that. OK, there's a few of you. Client-rendered JavaScript applications are basically one big bundle of late-discovered resources. Because what happens with this is you download a thin shell of HTML, which then will download your JavaScript, which will then create the virtual DOM, which then might inject your styles, which will then build the render tree, which will then download a web font. This is where we start to get kind of slow by default. 1.35 seconds to get hold of this font makes it a very late discovered resource. The good news is preload is here to help with that. Preload helps you find them sooner. In your index.html, in your main sort of HTML page, all you need to do in your head tags is pop this. You've got your link to your app.js. Next, we're going to preload our style sheet. Then we will also preload the web font. What this does is it removes that serialized download order and completely parallelizes it. So instead of being 1.35 seconds, we can theoretically collapse this down to 3/4 of a second. By declaratively fetching these files with preload, we can begin to parallelize everything. Mindful of time, I'm going to start speeding up a little bit. What I want to do is quickly talk through the attributes that come with preload. The as attribute is an interesting one. It used to be optional, but it is now mandatory. For a font, you would predictably use as equals font. The value of the as attribute is predefined. It's in the specification. You can't just make something up. We've got all these options available to us. And what the as attribute does, well, it does a few things. It's necessary to guarantee the correct prioritization. Make sure that fonts are treated more important than images, and that style sheets are more important than scripts, and scripts are more important than fonts, for example. That's the other way around. Fonts are more important than scripts. Request matching, application of the correct CSP policies, and all sorts of things are set by the as attribute. So it is now mandatory. By correctly implementing the as attribute, we will see that all of these preloaded files are downloaded with the correct priorities. Now, I can guarantee that at least 5 of you in this room have already had the same thought. You're probably thinking, well, I could probably hack this around. Surely I could start with this, but what if I did this instead? What if I downloaded style sheet like it's an image, or an image as if it's a script? I've tried this, and it turns out it doesn't work. It makes things substantially worse. You get a load of double downloads. The files can't be used. It makes things substantially worse. So don't try and hack this around. That said, there is a way to formally work around this. There's a new specification coming out. It's only available in Canary at the moment. Priority hints gives us a brand new attribute called importance. And that just takes the values either high or low, and this is how you can nudge around the priorities of different files. Next up is the type attribute, and the type attribute simply accepts a MIME type. This is very rarely used, but the best example I could give you is you might have a sort of a condition in which a browser does support preload, but doesn't support the type of file you're preloading. Safari does support preload. It doesn't support WebPs. So in this instance, it's wise to use the type attribute to tell Safari, you can't do anything with this file. You don't understand WebPs, don't download it. Finally, the cross-origin attribute is needed if you've got any CORS-enabled resources. Anybody know much about CORS and cross-origin stuff? Well, I don't, so I might come and ask you some questions. So basically, the short version of this, if, like me, you don't fully understand it, keep an eye on console. Whenever you're implementing resource hints, especially Chrome's developer tools will be very, very kind to you and tell you exactly what you're getting wrong. I built basically the most incorrect preload page imaginable, and we've got loads of helpful warnings here. The first one, I missed out an as attribute. The second one, I preloaded a file that never even got used, so it was wasteful. And the final one, I'd missed out the correct cross-origin sharing attributes, so it was rejected. This is the bad news. Preload is amazing, but there is some slightly bad news. If you buy me another Vermouth, I'll tell you why this is wrong. And it's Chrome's fault again. Chrome's got a weird bit of behavior in there that means that Chrome over-prioritizes preloads quite significantly. So here's a page where the fonts and the JavaScript are getting returned really early. This is good news. And the images that you can see, the purple towards the bottom, these take a little more time because they are just less important than those other files. My friend then decided to preload the fonts so that they arrive nice and soon. The problem is they arrive too soon. What's happened here is Chrome has over-prioritized preload, and it has stolen bandwidth from the fonts and the from the style sheets and the scripts, and given that bandwidth to the web fonts. The web fonts arrived too soon, and it made the style sheets arrive too late. The painful irony is that a web font is useless without the style sheet to apply it to the page. What will happen in Chrome is that whatever you preload will steal bandwidth from the actual most important assets. As of about a week ago, they came up with a solution, and I'm hoping that it rolls out pretty quickly. But unfortunately, I've been removing preload from a lot of my client websites because it is actually currently in Chrome a net loss. So that's the sad news. In fact, in this particular example, it made the site 400 milliseconds slower, which is terrible, right? I am going to have to blitz through the next part of this section. The last one is like the final boss. This is the big one, pre-render. The first two took domains. The next two took files. Pre-render takes pages. Pre-render will actually build a web page in the background silently for you. Download and build entire web pages in a hidden tab, so that by the time the user clicks through to that page, it's already built, it's already rendered, and it feels instant. Kind of. Not really, it's very, very complicated. So join me on this little emotional roller coaster as we go through the life and times of pre-render. The syntax is really, really simple. It is just rel equals pre-render and a path to a page. Browser support is terrible, 71%. Pre-render was such a bad idea that the IE team never ported it across to Edge. Now that's a pretty damning bit of evidence, isn't it? What pre-render does, In fact, if you cast your mind back to prefetch, with the YouTube example, we're downloading the videoplayer.js from the search results page. You probably can't see it here, but ghosted kind of really faint behind the search results page is the video player page in full. What we could do is not just download videoplayer.js from the results page, we could download the entire video page, including the video. We could, until they killed it. RIP pre-render. The reason they killed it was very, very, very wise. Nobody really thought pre-render through. It's full of holes, full of problems. What if a developer was like, oh, I'll pre-render my entire website? You know when you restart your machine and 50 different Stack Overflow tabs and Hacker News tabs try and open on your laptop and your fans start whirring? If you pre-render too many pages, it's just going to run down battery, it's going to use data, it's going to do a lot of bad. The browser does step in, and it will actually say, look, there are too many pre-renders, let's stop that. The problem here is it actually renders the page. So all of a sudden, clients of mine start seeing, oh my God, we've got 4 times as many visitors this month. And I'm thinking, oh, you don't, actually. We just pre-rendered too many pages. On the other hand, ad impressions go up, so that's pretty sweet, earn a bit of money. Things like interstitials, cookie warnings, timers, what do we do with those if they're in a hidden tab? And the biggest problem is security. If you get man in the middle and somebody drops a malicious pre-render on your web page, you could be browsing the, well, not this conference website because it's secure, but if you're browsing an insecure website that gets man in the middle, you could, unbeknown to you, like be running a crypto mining thing in the background in a hidden tab. So they killed it. Then they kind of brought it back, but they called it something nowhere near as cool, nowhere near as catchy. They called it no-state prefetch. Oh, come on, that's boring. So what happens now is you can still use pre-render. I told you this is a roller coaster, didn't I? You can still use pre-render. Pre-render is the API. Pre-render is the API. No-state prefetch is the mechanism. In what I think is quite a sensible move, they decided not to fully deprecate pre-render. Every website now across the internet that has a pre-render in its head tags, it doesn't just stop working. The syntax remained the same in order to preserve backward compatibility. What the Chrome engineers did is they changed how pre-render works under the hood. So the mechanism is now called no-state prefetch, which effectively means that pre-render will not render anything. So it's a bit of a backwards syntax, but you can still sort of use it. I'm going to quickly go through what no-state prefetch means for developers. No-state prefetch, I actually think of as a recursive prefetch. So think back to the example where we did a prefetch for videoplayer.js. If we had a few more files, we'd have to create a few more lines of HTML. Fetch videoplayer.js, fetch the SVG for the video player, fetch this, fetch this, fetch this. So our head tags start to get a load bigger. With no-state prefetch, what you can do is a recursive prefetch. You pass in a HTML page, and that acts as an entry point. So instead of prefetching each individual file for a certain page, what you can do is prefetch that entire page, and the browser will then look through it. So from page A, we can pre-render page B. The browser then opens up page B, and it will go and find all the sub-resources. So it's basically a recursive prefetch. The syntax is as simple as this. So it is, this is from a demo page, just preloading my entire homepage. It's all, again, fetched with the lowest possible priority. So what's going to happen is the current page will load. That's the blue line. And then recursively, after the load event has fired, it will open up the CSSWizardry.com homepage and download everything inside of that. So this is a really powerful mechanism for pre-browsing. I have unfortunately gone a little bit over time. The last part of the talk was going to be some tips and tricks and gotchas. What I'm going to do is I'm going to skip that just to kind of respect your time a little more. But the full slides are already online, and there's a Q&A coming up next. But there were some tips and tricks and gotchas. You can do things like deploy them as HTTP headers. You can do stuff like more edge bugs. You can generate them dynamically. You can create these based on user interaction with JavaScript. So as a user hovers a certain button, you dynamically inject a prefetch, perhaps. Oh yeah, and then that's a big warning. We'll cover that in the Q&A. That's in the slides already. But just to start winding down, oh my goodness, there's loads of bugs. I'd forgotten just what a minefield this was. Yeah, that was it in a nutshell. So resource hints, really, really powerful specification. Actually surprisingly mature at this point. And I can almost guarantee that any website or application that you're working on could implement some resource hints effectively immediately. So I'd urge you to look into it. The benefits of it are absolutely enormous in the right circumstances, and the cost of implementation is literally just single lines of HTML. Cool. Well, thank you so much for listening to me. That was a bit of a blast, so I'll make sure you get the slides. In fact, you can see what we were doing yesterday in the workshop. Thank you very much.